Hey everyone, in this video we're going to learn how to write the equation of a parent function after multiple transformations have occurred. As a reminder, our transformations are scaling, reflection, and translation. Our first example, write the equation in y equals form of the given function after the described transformations have been performed in the given order. Our first function is y equals x squared, and our transformations are a vertical stretch by a factor of 6, followed by a move right 2. So we're starting with y equals x squared, and our first transformation is a vertical stretch by a factor of 6. Okay, so that's a scaling, and if we're vertically stretching, we're multiplying the y values by that value of 6, x by nothing, so 1/6 is our scale factor. Right? If x is unchanged, we still need to multiply by 1 instead of 0. So in our function, we are going to have y divided by 6 equals x squared, which would be y equals 6x squared. Next, we're going to move that function to the right 2. So moving to the right 2 means we add 2 to every x value. So 2 and nothing to the y's. So in our function, we have y equals 6, and then inside the parent function, if we're adding 2 to the x, then in the function we're subtracting 2, so it's going to be x minus 2 squared. So this allows us to bring up a reminder that our function is always telling us how to get back to the parent function. So if we're adding 2 in our translation, the function is going to subtract 2 from the x values to get back to the parent function. If we're multiplying the y values by 6, then we're dividing by 6 in the function to get back to the parent function. Next up, we have y equals the cube root of x, and the transformations are a reflection over the x-axis, followed by a move left 1 and down 5. So we have, let's get a better y there, we have y equals the cube root of x. Okay, so first we have a reflection, which we're going to think of as a scaling of a negative value. If we're reflecting over the x-axis, that means we're negating our y values, and there's no other scale factors here, so our scaling is just 1, -1. We're multiplying every y coordinate by -1. So then we're going to get, let's do that, I want to do that in blue, just so we have a little contrast there. So our scaling is 1, -1. Okay, so in our function, we have y divided by -1 equals the cube root of x, which is y equals negative cube root of x. And then we're going to move this function left 1 and down 5. So we have translation. So left 1, we're subtracting 1 from the x values. Down 5, we're subtracting 5 from the y values. So in our function, we have y plus 5 and negative cube root of x plus 1. Again, that whole idea that the function is telling us how to get back to the parent function, so opposite the transformation. So in y equals form, we have y equals negative cube root of x plus 1 minus 5. Okay, not too bad. Same directions. Our function is y equals square root of x, and the transformations are a vertical compression by a factor of 1/2, a reflection over the y-axis, and we're going to shift up 1. So y equals square root of x. So we can either do this in 3 steps, 1 for each transformation, or we could recognize that the vertical compression and the reflection, since they're consecutive, one after the other, we can do it at once. So we can think of this as a scaling. So a vertical compression by a factor of 1/2 means we're multiplying the y values by 1/2. Reflection over the y-axis means we're negating the x values. So multiply each x value by -1. So we can combine them in a scale factor of -1, 1/2. If you don't see that, then do it step by step. Do a scaling of 1, 1/2 first, then do a scaling of -1, 1. You'll wind up with the right answer. You'll just have one extra step. So applying this scale factor, so we're going to divide y by 1/2, and we're going to divide x by -1. So simplifying this, we have y equals 1/2 times the square root of x divided by -1 is just -x. And then we're going to shift this function up 1, so that's a translation. So up, so we're adding nothing to the x values and 1 to the y value. So in our function, we have y minus 1 equals 1/2 times the square root of -x. So y equals 1/2 times the square root of -x plus 1 in y equals 4. So this was a little more difficult because now we had 3 transformations, but as long as we take it step by step, our work doesn't change. Next, we have y equals the absolute value of x, and our transformations are a horizontal compression by a factor of 1/4, shifted left 3 and down 4. Okay, so we're going to start with the absolute value function. So first, we have a horizontal compression by a factor of 1/4, so that's a scaling. And horizontal compression, so we're multiplying the x values by 1/4, comma 1. So in our function, we have y equals the absolute value of x divided by 1/4. And we can simplify that, so that's y equals the absolute value of 4x. And then we're going to shift that function left 3 and down 2. So left 3 means we're subtracting 3 from our x values. Down 4, we're subtracting 4 from the y's. So in our function, we're going to have y plus 4 equals the absolute value. Now we're subtracting 3, but in our function, we're going to add 3 to the x values, and only the x values. So I need parentheses here. So it's 4, and then a set of parentheses, x plus 3, inside of the parent function, which is the absolute value. So we can clean this up, so y equals absolute value, so we can either leave this factored, or if we really want it nice and simplified, we can say the absolute value of 4x plus 12, and then we can subtract the 4, and there would be our function. So this one's a little tricky because we had 2 transformations both happening to the x values, and the really important piece is when we went to do that translation after the scale factor, we had to make sure that the x plus 3 was in parentheses, right, because it was happening after the fact. Same directions. Now we're starting with y equals x plus 1 quantity cubed. So this has already been translated, and then we're going to follow that up with a vertical stretch by a factor of 4, shifted right 1 and up 1. Okay, so we're starting now with y equals x plus 1 cubed. So vertical stretch by a factor of 4, so that's going to be a scaling. Vertical means we're multiplying the y values by 4, so scaling of 1, 4. Okay, so in our function, we're going to divide y by 4, then x plus 1 cubed. So y equals 4 times x plus 1 cubed. And then we're going to follow that with a shift right 1 and up 1. Okay, so we're adding 1 to x, 1 to y, in a translation. So in our function, we have y minus 1 equals 4, and then again, we're adding 1 to the x, so I'm going to put another set of parentheses, so x plus 1, x minus 1 rather, right? It's always opposite, don't want to make that mistake. So x minus 1, and then the plus 1's outside that parentheses, cubed. So we can simplify this, so y equals 4. Now inside of the parent function, we would have x minus 1 plus 1, which is really just x. So then that's just x cubed, and then add 1 to the other side. So this actually creates a simpler function inside of the parent function after we do our transformations. Next up, we have y equals -2 times the square root of x. And we're transforming it by a horizontal stretch by a factor of 3, reflected over the x-axis and translated left 2. So let's see what we got. So we got y equals negative 2 times the square root of x. And what are we going to start with? Okay, so we can combine the horizontal stretch and the reflection into a single scale factor. So a horizontal stretch by a factor of 3. So we're multiplying the x values by 3. And reflect over the x-axis, so we're negating the y values. So multiply the y's by negative 1. So we have y divided by negative 1 equals negative 2 times the square root of x divided by 3. Right? Always opposite when we're going into our function. So that's y equals 2 times the square root of x divided by 3. And then we need to move it left 2. So we're going to subtract 2 from the x values. So we have y equals 2 times the square root. So in the numerator, because that's where x is, we're going to have x plus 2, and that whole expression will be divided by 3. So there we have our function after it's been horizontally stretched, reflected, and translated. Write the equation of y equals f of x after the described transformations have been performed in the given order. So first transformations, they say a vertical stretch by a factor of 2, horizontal compression by a factor of 3/4, and shift left 9. Okay, so we're going to start with y equals f of x. So we can combine the vertical stretch and the horizontal compression into a single scale factor, or you can do them separately. Choice is yours. So vertical stretch by a factor of 2, so we're multiplying y values by 2. Horizontal compression by a factor of 3/4, we're multiplying x by 3/4. So our scale factor is 3/4, 2. So in our function, we have y divided by 2 equals f of x divided by 3/4. So that's going to be y equals 2f of, so dividing by 3/4 is multiplying by 4/3, so 4x over 3. And we're going to follow that up with a shift left 9, so translation. We're going to subtract 9 from the x values, nothing from the y's. So we have y equals 2f of, x is in the numerator, and we need to put our translation in parentheses because there's also a 4 up there. So we're going to replace x with x plus 9 over that 3. And we can leave it here, or we could distribute out the 4. The choice is ours. In this case, let's leave it. So there is our function. Next up, if the graph of y equals f of x minus 3 plus 1 is horizontally stretched by a factor of 7, then move left 6 and up 3, what will the equation of the new graph be? Okay, so we're starting with y equals f of x minus 3 plus 1. And we're starting with a horizontal stretch. So a scale factor of 7, 1. And multiplying the x values by 7. So in our function, we have y equals f of, in our function, we're going to divide x by 7. Now just x in this case. So x over 7. And then minus 3 plus 1. Okay. And then we want to apply a translation. Left 6, up 3. So we're subtracting 6 from x, adding 3 to y. I'm going to need to go a little below. So y minus 3 equals f of x plus 6 in that numerator over 7 minus 3 plus 1. So cleaning it up, we can write this as y equals. Now it's kind of weird having a fraction then minus 3. So we can think of 3 as 21 over 7, and we can combine our fractions then. So that's going to be x minus 15 all over 7 plus 4. Okay, so again, a little bit of a challenge here, but if we can wrap our head around this idea, then we're in really good shape. So first thing, if we're scaling the x, then the only thing that's changing in the function is the x. So we're dividing x by 7. I don't care about that minus 3 inside the parent function. We could have combined the terms here, and it might have been a good idea before we did the translation, but we left it alone. Then we translated, so we replaced x, right, or we added 6 to the x. Now the x was in the numerator, so I added 6 to just the numerator. And then we subtracted 3 from y, and then from there, it was a matter of simplification. Now we have to learn how to write the equation when we're given a graph. So write the equation by identifying the parent function and transformations in the correct order. So looking at the graph, we can see that the parent function is going to be y equals x squared. So we want to keep our thought process the same. We always want to look for the scaling first, followed by the translation. So the way we're going to figure out what the scale factor is first is treat this as the origin. Okay, so in this case, the vertex of the parabola is going to be the origin. And if we think about the parent function, that would be 0, 0, and then we'd have 1, 1, negative 1, 1. So we have points on that parent function we can compare to the graph they gave us. Okay, so how did they scale these green points to get the points on our red graph? Well, let's see. It's reflect over the x-axis, so we're negating the y values. So let's start simply by multiplying the y values by negative 1. So 1 becomes negative 1. Well, that works. And then there would be a 4 here, and that becomes negative 4. Okay, so we have our scale factor figured out. It's a scaling of 1, negative 1. Now, after it's been scaled, remember we're thinking of this as the origin, this really isn't the origin though. So we would have had points all over here. How did they get over here? Well, they were moved to the left 4. So that's a translation. Left 4, so we're subtracting 4 from our x values. Okay, so again, let's just recap here. I want to think of the scaling first, so we want to take that vertex, in this case, think of it as the origin. Draw a few points for the parent function. If this is 0, 0, then that's 1, 1. Compare them to the graph they gave us. Figure out our scale factor, and then once we have that down, how were the points translated from the origin over here to the points that they're at. In this case, we can see that they're moved left 4. So now we use these scale factors to write our equation. So we're going to start by dividing y by negative 1. So we have y equals negative x squared. And then we're following that with a translation of negative 4, 0, so that's negative. And inside the parent function, x plus 4, quantity squared. And with all of these that we write, when we're given a graph, plug in a few x values and see if they match up. For instance, if I plug in negative 1, I should get negative 9. So I'd have negative 1 plus 4, which is 3, squared is 9, times negative 1 is negative 9. Works out. Up next, same directions. Parent function is y equals the square root of x. Okay, so again, let's think of this point, the end point, as the origin. Okay, so 0, 0, and then there would be a point 1, 1. So we have to figure out how those points on the parent function became the points on the red graph. Well, first, there's a reflection over the y-axis. So that means we have to negate our x value. So we have to multiply by negative 1. But if we did that, that would just bring me over here. I need to get up there, so the y value is also multiplied. Well, the y value here is 1, and the y value here is 2. So we also are multiplying the y value by 2. Okay, so we have our scale factor. Right? Take our points, multiply them again. Remember, this is 0, 0. We're thinking this is the origin, so this is the point 1, 1. This is negative 1. Okay, so we'd have 1, 1 goes to negative 1, 2. Okay, matches up. And then we can see 4, 2. I know we can't see it on the graph. Multiply, we'd have negative 4, 4, right? So 1, 2, 3, 4, negative 4, 1, 2, 3, 4. Okay, matches up. Scale factor is good. Next, we got to follow that with a translation, right? Because these points aren't at the origin. Well, it seems after they were scaled, then everything was just moved right 1. So translation of 1, 0. Okay, so let's put these transformations into our function. So we have y divided by 2 equals the square root of x divided by negative 1. So that's y equals 2 square root of negative x. And then we have a translation of 1, 0, so we have y equals 2 times the square root of negative, and then in parentheses, x minus 1. And we can distribute that out if we would like. But that is our function. And again, we can plug in to make sure it checks out. All right, our last graph. Here our parent function is y equals the absolute value of x. And we want to figure out how it was transformed. So let's take the vertex. That's the origin. Okay, that's 0, 0. So then we'd have 1, 1, 2, 2, negative 1, 1, negative 2, 2. So those would be the points if this is the origin. So how were they scaled? Well, I see a horizontal scaling. You may see a vertical scaling. But I see that this point was multiplied, so 1, 1. This point would be 3, 1. Again, this is the origin. So x was multiplied by 3. So we have a scale factor of 3, 1. And then it was translated to get up there, so all the points were moved left 2 and up 4. So left 2, up 4. Okay, so let's write our function. So y equals the absolute value of x divided by 3. Then we're translating, so y minus 4 equals the absolute value of x plus 2 divided by 3. So in y equals form, we have y equals the absolute value of x plus 2 divided by 3 plus 4. All right, one last question to get our brains working. How is the graph of y equals negative 3 times the absolute value of x divided by 2 plus 1 transformed to produce the graph of y equals 3 times the absolute value of x plus 11 divided by 2? Okay, so the best thing to do is let's figure out how both of these are transformed in comparison to the parent function. Okay, so let's start with y equals negative 3, absolute value of x divided by 2 plus 1. Okay, so let's rewrite this. So y minus 1 equals negative 3 times the absolute value of x divided by 2. Y minus 1 divided by negative 3 equals the absolute value of x over 2. Okay, so compared to the parent function, so we're comparing, write this, comparing to y equals the absolute value of x. Okay, so we have a scale factor of 2, negative 3, and a translation of 0, 1. Right, always opposite what winds up in the function. Now let's take the other function, y equals 3 times the absolute value of x plus 11 divided by 2. Let's rewrite that. So y divided by 3 equals the absolute value of x plus 11 over 2. So our scale factor is 2, 3, and our translation is negative 11, 0. Okay, so now the question is, how did we get from these transformations to those? Okay, so scaling 2, negative 3 to scaling of 2, 3. So it looks like the y was multiplied by negative 1. And then how did we get through those translations? Well, it looks like we subtracted 11 from the x's and we subtracted 1 from the y's. Right? 0 minus 11 is negative 11. 1 minus 1 is 0. 2 times 1 is 2. Negative 3 times negative 1 is 3. Okay, so now we just have to describe these transformations in words. So if we're multiplying y by negative 1, we're reflecting, so reflection over the, if negating the y, we're reflecting over the x-axis. Then a shift, let's see, so minus 11, so we're going left 11, and minus 1 down 1. Okay, so to get from our first function to our second function, reflecting over the x-axis, shifting left 11, down 1. So this game is definitely a little more challenging, especially in the writing of the graphs. Okay, so try a few of them, but don't get too hung up if you're finding it difficult. And most of them will keep pretty simple with one scaling, one translation to identify. And then practice with your writing, okay, and really emphasizing that idea of the equation telling us how to get back to the parent function. Right, so our transformations are opposite what shows up in the function. Okay, so go off and practice and make sure that you feel comfortable and confident with our transformation unit. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.